Bonsoir. Welcome back. How is everyone? Comment ça va? Bonsoir Luc, 27, ça va Marcel, Jean, Marcel, ça va bien. Ça c'est bon. Dosnar. Miguel, Michael, Michael. So how was your morning? Did you meet with Taylor? How did it go? Good afternoon, Samuel. So you ready for 6 hours of lecture? So my goal is to finish this notes in the first portion of today and then start, do some review problems and then start the next portion. But pretty much your test for the week will be on this portion. Hello, Kelly, Louis Charles. I'm very confused about first and last names, but I would say Louis Charles is probably, well, actually, I don't know. That could be your last name. Jean is here. Very good. So did you meet with Taylor this morning? I'm thinking that maybe I will give you the test or assignment on Tuesday like I did last week so that you can spend Sunday and Monday reviewing the documents I already gave you rather than focusing exclusively on the test. Ah, you did not meet with Taylor. Okay. So tomorrow you meet with Taylor? Will you meet with Taylor? Is there a plan? Good afternoon, Ironel. So Tuesday and Thursday you meet with Taylor. Okay. All right, well, you guys should take some time to review on your own then, in preparation for those sessions with Taylor. Thursday is a good time to review, then you're fresh on Fridays, right? So that's pretty good. All right, so shall we start? 5 minutes in, almost 10 students. So last class, we began the topic of looking at alternate techniques to valuing projects. And I talked about the different kinds of analysis. You can do an independent project analysis where you evaluate each project on their own merit. We're also going to talk about mutually exclusive projects today. Those are where you have to pick one of several options. And then capital rationing is the case where you have enough financing to select more than one, but not all projects, and you have to decide which combination is the best. So projects are like, for instance, a company wanting to expand, right? So then they want to expand. They are a chain of grocery stores and they want to expand to another city. And that could be considered like a project, an investment project. Or a manufacturer wants to produce a new product and they have to consider the potential revenues and the expenses of doing that. And those are alternative projects. And for now, I'm giving you cash flows and asking you to analyze. We began with analyzing using the net present value rule. And then I taught you about what's called the payback period rule, which is this is a knee-jerk kind of thing. When you find out about a project, somebody wants you to loan them money because they want to pursue something, you're considering investing, or you are yourself a business owner looking at taking on a new project, expanding, buying a building, duplicating operations, these sorts of these are examples of projects. And you just want an idea, if I invest now, or if the investor wants to know, if they invest today, what's the chances that they will get paid back in 2 years? Or when will they get paid back their initial investment? And so we learned about that, and I talked about how it would be better to include, discounted cash flows in the analysis as opposed to just cash flows. It doesn't change the decision in this example that I gave you, because I was using 2 years as a cutoff. If projects take longer than 2 years to pay back the initial investment, we would reject the project. In both cases, it's the same. But if I use a different threshold, like two and, if I use 3 years, they would both be rejected. If I use 2 years, 2.6 years, this one would be accepted, but this one wouldn't. So these do result in different answers with maybe potentially different conclusion. So you need to know the difference. I taught you how to make the calculation. I talked about the disadvantage being that you might not include consideration of future cash flows. Often the future, maybe there is some detrimental event that you anticipate, and that will be very costly. So even though the project paid back in the given amount of time as an investment opportunity, it's not a good idea because there'll be a big loss in the future. So I suggested you don't use payback period or the discounted payback period rule alone. You use it with something else, like the net present value that looks at all the cash flows. And then we began our discussion of the internal rate of return. And I began by saying that net present value is a dollar amount that you get. Payback and discounted payback period rule gives you a time as a measure. And internal rate of return gives you a percentage. And the way that we interpreted that yesterday was we interpreted it as a percentage return on investment, not a dollar return or not a time till return. It's the percentage return. But it's not without its challenges. Okay, so it's a good approach because you get a single value to report. With a single value, you can summarize the value of the project. So 23.3 is a very high return on investment in the project, and provided that the owners or management or the potential investor considers that suitable, then you accept the project. So what is suitable? Well, they should have in mind some sort of required rate of return to compare it to. So if 23.3 is bigger, since 23.3 is bigger than 15%, in this case, you would accept the project. But if the required rate of return was as high as 25%, you would not. You would reject the project. So then I explained the development, the creation of the NPV profile, we can compute it by taking this using our calculator, which takes this expression for NPV and sets it to 0. So the idea is find the discount rate for the project that just breaks even. What is the discount rate that doesn't have a profit, but it also doesn't have a loss? It's just break even. So that is what we're calculating, and it's impossible to do this with analytical techniques. Like, you cannot isolate IRR algebraically. Rather, the calculator is necessary, and this is why you have a finance calculator. The finance calculator will do this for you, okay? And it does it by iteration. It does something like this. It starts to put values in, and it checks at what point does the NPV become negative. It goes from positive to negative here. So I said, then what the calculator will do is it will focus in and iterate in here, and it will check what happens to that equation with 21% as a discount rate. And that one, sorry, it's looking for a negative, but this one, when you punch it in, will be positive. This one will be positive. This one will be positive. We did this yesterday. And then this one will be negative. So we know that the IRR is in there. And you keep on iterating. You then blow up this area and do the same thing. You check 23.1, 23.2, 23.3, and you look for where it's closest to 0. And it turns out that IRR is between 20 and 25%, which we already decided, but with the calculator you can get the precise value, or even with what I've done here, I've shown that it's between 23 and 24. And in fact, it is 23.3. Okay, so any questions so far? Do you understand where I got this from? Okay, so to find this one, so we're going to use this equation. What we're going to do is use this equation, and our calculator, it has it already programmed. So let me take it here. Sorry. So what it does is it calculates NPV for this equation. So you put in different discount rates. So what you do is go to the calculator, put in these cash flows, and then put 5% as a discount rate, and you'll get this number. So let's repeat that one. So we go to the calculator and we enter those cash flows. I'm trying to keep it here. Okay, so let's put these cash flows in our calculator. So we go to CF, we have to clear it. Actually, I think the numbers are already there, but let's clear it to start over, and we enter $2,200 negative as the initial outlay. Enter, down, and then 800. Enter, down, down, because there's only one frequency. And then 900. Enter, there's only one. And the third one is 500. Enter, down, down, and then 1600. So we're done. To review, we have 2,200, 800, 900, 500, and 1600. And then we ask for NPV. Of course, we have to put the discount rate in. No, sorry. We want to put the discount rate in. And yes, that's what we want to do. Put the discount rate in. And we're going to pick 5%. Enter, down, and then ask to compute the new NPV. And there you go. There's the value, 1,126. So what we do is we calculate the profile. I'm calculating this for NPV and generating all these. This is our goal. We want to find where this expression is 0. That's what our goal is. Okay, so this is the way the calculator does it. So as I explain, entering different values of the discount rate, you see this is going down and then crosses over. So it means that somewhere between 20 to 25, NPV was 0. So we need to find where that is. So what I suggested was, then the calculator, what it would do was expand and look at 21, 22, 23, and those are all positive, keep on going. At 24, this will be a negative. So I'll show you if I put 24 in there. Oops, if I put 24 as the discount rate and I recompute NPV, I see a negative value. So because this function is known as a monotonous function, a monotonous function. For every value of r, as I increase, the function goes down. It means that in here, between 23 and 24, must be where NPV is 0. So you leave it to the calculator to do it when you can, but when the calculator cannot find the solution, you have to use this method. This is called the NPV profile. So we're going to do this for several exercises. Okay? You'll have some practice. Any questions? So this is the function we're talking about, and we're plugging in new values of the discount rate, and we see between here and here, the NPV was 0, must be, because it crossed over. So up until this point, the NPV is positive, and that's important. That's the thing that's important. NPV is positive means accept the project. So accept the project as long as the discount rate used by the company is less than this. In other words, the internal rate of return will be better than what's required. I'll put it in words. Exactly. We're finding the breaking point, break-even point. Mm-hmm. Okay. Now, if IRR is not exceeding the required rate, if the required rate was higher, so if the investors or the managers wanted a return that's 25%, then the cash flows would give a negative NPV, and you should reject the project after this point. In other words, the return on the project is not enough to meet the standard. All right, so let's look at the next problem. Ready? So here's a new problem. What I want you to do, you do have the notes and you could go through and see the answer, but what I want you to do is generate the NPV profile for this problem, and then we're going to discuss it. So generate So what you want to do is you use a percentage and you calculate the NPV. So you can use, let me just see, go to 20. Okay, so we're going to go 0, 5, 10, 15, 20. So clear your cash flow keys and start over again. This is your initial outlay. This is CF0. Notice that it's a positive. So this is different from an investing project. It's called a financed project. So up front you have money given to you and then you deliver the services, you see? So these are the negatives to offset the positive. And you can still analyze it. Okay, so let's look at that. I'm going to give you a few minutes to do that yourself. Okay, so let's see. We're going to put these values into the calculator together. So I'm going to go to CF and I'm going to say second, clear work, clear it up, and then start entering. First, 4,000 is a positive because it's a finance project. And put it, the next one, 1200 negative, enter, down, down. 800 negative, enter, down, down. And 3500 negative, enter, down, down. And then ask for the NPV, and it's asking for a discount rate. So we begin, put 0 in first, enter, down. Now ask to compute NPV. And so that's the first value, negative 1,500. Then we put 5%, so hit NPV again. Then tell the calculator enter 5, enter down, and recompute NPV. So now it's negative 891. I'll transcribe these in a moment. Then we hit NPV again and change it to 10%. And then ask to compute. You enter it and then you ask to compute, recompute. So it's still negative 381. So you do that all the way, do 20 now. Did I use 15 yet? No, 15. So now we hit NPV, enter 15, enter down, and recompute. Aha. It became a positive. So between 10 and 15% is the answer. So let me put those into the chart. So my answer so far, I've got negative 1,500, negative 891, 91 if I want to put the cents, and then minus 381, and then I got $50. So on the next page, here are the values, okay? So what you see here, has everybody caught up? Does everybody know how to get this before I continue? So we are trying to find the place where NPV is 0, the break even. We could get it out of our calculator directly, but I want to generate the profile so that you understand what you are computing. So you see the NPV is going down, 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 up until here. In fact, if we go to the calculator and ask for the internal rate of return, we will find that it's between 10 and 15. Let's do that. That's not it. Let's ask the calculator to compute IRR. So I press IRR and compute, and there it is, 14.374558. How is the sound? Is the sound clear? Right. So what is the difference this time compared with the last example? This time, we are doing what we did before, setting the NPV to 0 and trying to solve for the rate that does that. So the issue is, however, that the initial cash flow is a positive and the subsequent cash flows are a negative. So as IRR goes up, the other overall number goes down. But this is down in terms of negatives. So in reality, it's less negative. In other words, it's going up positive, right? It's getting more positive. It's actually increasing. When you plot this, you see that the NPV profile increases. That's what we see here. As you put higher discount rates, this goes higher. So what is the interpretation? It's opposite. I began with a positive cash flow and then negative cash flows. So how does that change my result? Comments? Are you still making these calculations? Let me know. Are you doing this profile? Everybody has this result? Yes, 14.37 is the IRR. So if you don't have a finance calculator, you will not be able to get this exact value, but you can see here that it must fall between 10 and 15. So what you should do, if you didn't want to get, or you couldn't get a finance calculator, is you expand between there and you keep on entering values to the NPV profile. And what you're going to find between 10%, which is negative, and 15%, which is positive, you will find that these will all be negative until 14, and I can show you on the calculator. If I go back and put in 14 and compute, it's still a negative. If I go back and put $15, remember, it's positive. And all the others would be negative. This is because the function is all in one direction. So slowly it's going to go positive towards the positive. It's getting less negative, so this amount overpowers this amount and it gets closer to 0. So that's what you see in this pattern. It's becoming more positive until here, and that is the break-even point. All right, so yes, Jefferson, it's correct. $14.37. Is that what it says? I get 14.37, not 14.34. So again, in my calculator, I asked for IRR and it's 14.37. Okay, so what is the interpretation? It's an inverse curve, so the interpretation should be the inverse. What we do this time, because it's a finance project, it means that our investment is perceived as borrowing money up front. And when we borrow money up front and then deliver services, the rate that we perceive is like a borrowing rate. And we want that borrowing rate to be lower than the required rate of return. It's the opposite, okay? So finance projects where you begin with a positive cash flow and subsequent cash flows are negative, the IRR result is not interpreted as a return on investment, but as a borrowing rate. And we want that rate to be lower than the required rate of return. Okay, so we reverse the conclusion. So for instance, if the required rate of return for a project is 15%, in this case we would accept the project because our rate, the IRR, is 14.37. If, however, the required rate of return is 10%, we would reject the project. So I really need you guys to understand. So I have the NPV profile here and you see it makes sense. We should only accept the project in this region with these discount rates because that's where NPV is positive. questions? So we're going to, from here on out, we're going to refer to projects with a that have an investment, so a negative first cash flow, and then all the rest are positive, so they only change sign once. That kind of a project will be referred to as an investment project. In that case, the internal rate of return should exceed the discount rate. In other words, we interpret it to mean that this is the return on the project and it has to exceed the required rate of return. If instead our project begins with an influx of funds, financing, it's different. This is a financed project. It means that the first cash flow is positive and then all the others are negative. In that case, we interpret the internal rate of return as a borrowing rate, and it should not exceed the required rate of return. The NPV profile is flipped, and our project will only have positive NPV provided the discount rate is better than that borrowing rate, or the internal rate of return. Okay, so we have two kinds of projects with two different uses of the internal rate of return. If you don't have questions, I'm going to continue. So what if the signs change from an investment, and here's some positive revenues, but then there's a negative cash flow out in year 4? That's two sign changes in the cash flows. It goes from negative to positive and then positive to negative. How does that affect our polynomial? How does that affect our expression for the NPV? Well, now it's going to have a curved feature. That's just because of the sign changing. So, and it also means that you can have up to 2 internal rates of return. And you can see that in the curve. It could be that the curve does this, and then look, you'll have 2 IRRs. So what we do is we use our calculator when we can solve this, but we need to understand the interpretation, because as you see, it's not always the same thing. Depends on the relationship of the cash flows. Well, you can just say words, Jeffson. This is the internal rate of return. And this is the required rate of return. So I think it's better if you just remember for now that this one is the one you calculate, and this is the one that is set by management. So it could be the case that the curve never touches, it never becomes NPV 0. What should you do in this case where the NPV profile is always positive? There are no IRRs, but we still need to know what to do. In this case, since NPV is always positive, no matter what discount rate you use, accept the project unequivocally. Yeah, Justin, sometimes you use the same words for different things. So the formula, my approach in formulas is to use the same formula for different settings. So yeah, face value could be future value in terms of the bond calculation. Okay, so back to this. What if the project is always, the NPV profile is always below NPV of 0? Again, there's no internal rate of return. It doesn't cross this line. But unequivocally, you should reject the project. For any required rate of return, no matter what the discount rate set by management is. Right. But sometimes it's going to cross. So what do we do in the situation that it crosses? So that's what we're going to discuss next. Here are the cash flows for a project. And here is the NPV profile. So begin by entering these into your CF keys and determine if you can find any of the IRRs. So let's see if we can do that. So we go to the CF keys, we clear, second clear work, and we begin to enter 260 negative, enter down 250, enter down, down 300, enter down, down, and then 20, enter down, down, and then the negative 340. So the idea is you can have up to 2 IRRs because they're 2 sign changes. So now we ask for IRR. There's no answer. You have to hit compute. And there is 11.52. So 11.52 turns out to be one of the results. But there is another one. There is another result, and some calculators can calculate both, but most calculators cannot calculate both. Okay? If you have a Hewlett-Packard calculator, you can store a value above that overshoots this one, and the calculator will iterate towards the other IRR, but with the TI-BA2 Plus, you cannot get it. You will not be able to get it. So, what you need is the NPV profile. That will help you get there. So here I have all the percentage rates with all the different NPVs, and I see that it goes from negative to positive right here. So I should expand between 10 and 15 to look for where it becomes a positive. See, it's approaching 0, and the 0 is somewhere in here. And then here, it begins to increase, but then goes down again past 0 between 25 and 30. You can iterate and try and find this one. So when I mean iterate, when I say iterate, that's where I mean to go use 10, 11, 12, 13, 14, 15. You're actually going to find it right away, so I don't need all of these. I just need 12. So when you enter 10, 11, and 12, so I hit MPV and I do 11, enter, down, compute, it's a negative 0.635. When I enter 12, and compute, it's a positive. So it's between 11 and 12. So what really matters is getting closer and closer. So this was a negative, but then this one was a positive. So then you need to go between 11 and 12, and you could say 11.1, 11.2, 11.3, 11.4, 11.5, 11.6. So you can keep on expanding to try and find closer and closer to where you get. In this course, I'm happy if you get 1. And then the other one you can just approximate. So there's another one here between 25 and 30. So this is the NPV profile. Now you should be able to sketch that. It's a smooth curve, so you can smooth your values together. And how do we conclude? That's the most important thing. How do we conclude? We look where NPV is positive. So then NPV is positive between here and here. It means that you should only accept the project provided that the rate of return required is between 11.52 and 29.84. Is that realistic? Yeah, some investors require at least 12% because otherwise they could get that on the American stock market. And they wouldn't have to invest in people's projects. So maybe they want higher. Maybe they want higher because this is there's some uncertainty with this possible expansion of this company. Let's say that's what the project was. And so they want to be guaranteed, or they want a return on investment of 20%. So they want this return. In that case, it would be a positive NPV project, so you should accept the project. Anywhere outside of that, reject the project. So all I'm doing is giving you cash flows, and you have to analyze them. Make an NPV profile, because it's not enough just to get the value out of your calculator. It's not the whole answer. Here's another one. Try this one. So I'm going to give you, it's 2 o'clock, I'm going to give you 5 minutes to do that, and I'm going to come back and see if you have any questions. I'm just going to say, Okay, I see some of your questions. It is not that we're looking for NPV to equal 0 per se. We are using it to help us find this breaking point, this break even. This is where the project has NPV 0. This is where the project has NPV 0. So these are the discount rates that give an NPV 0 here and here. The project is only profitable where NPV is positive. So you have to realize what this line is changing the discount rate. We're changing the terms that we use to decide if a project is profitable or not. So when I ask you to make the NPV profile, you're going to start with the idea that this must be curved, and because it goes from negative to positive and then positive to negative. Two sign changes mean that there's going to be a curve in the NPV profile, and that means there's up to 2 internal rates of return. In this case, it actually goes down like this. You will see you have to go as far back as negative 30 to find one of them. So you would have to start negative 30, negative 20, negative 10, 0, 10, 20, 30, 40, 50, 60, 70. You have to check to try and find it. Find where the NPV is 0. So you are not looking, you don't accept the project with NPV is 0. That is just the threshold that marks where it's not a profitable project, and you have to look and consider where it is. In this case, it's profitable between here and here. As long as the discount rate that you've set, management has set, or an investor expects as a rate of return is between here and here, you should accept the project because that makes NPV a positive. So it's really here. No one's going to use a discount rate that's negative. A negative discount rate would mean it's like it's an interest rate, right? This is the rate of return. Who would expect or require a negative rate of return? That doesn't make sense. Rates of return are usually bigger than 0, right? Should be bigger than 0. So you would accept this project provided the return is between 0 and 72.25. So let's generate those numbers. Let's generate those numbers together. So why am I making the profile go like this, like all the way back? Because I want to see the pattern. I want to see the pattern if it goes, yeah, I need to see the pattern. What happened? It closed on me. So let's put this in our calculator. Going to the calculator, I want to go to CF and clear, second clear work, and start over with the initial cash flow is 900 negative, so it looks like an investment project, but then it goes to 1200, so that's good. It's positive, there's one of those, and then 1300, it's positive, so one of those, and 1200 negative, and there's one of those. Now second, sorry, I don't need that. What I want to do next is ask for NPV, it asks for the discount rate, and I can put 30 negative inside and enter it and ask the calculator to compute. So I get negative $31 for negative 30. So I put that here. Now we'll try for 20. Put in 20. What do we get? I'm going to hit NPV, enter 20, enter, down, and recompute NPV. Now it's positive. So it already crossed 308. So this means that in between here, NPV must be 0 because it's a smooth curve and it went from a negative to a positive. And then you keep on entering values and you're going to see these are all positive all the way through. I'm going to enter negative 10, NPV, 10, negative, enter, down, recompute, positive. Let's enter negative 5, 5 negative, enter, down, recompute, it's still positive. So you keep on going. Let's put 0 in, 0, enter, down, compute, it's still positive. So this is going to happen. All these will be positive all the way down until after 70. So I put 70 in there. So that's the discount rate the company might want. 70, enter, down, compute, still positive. Now let's put 80. 80, enter, down, and now it's a negative. So what have I done? What I've illustrated is displayed in the graph. There's going to be an internal rate of return in here and one in here. And how do we conclude? We conclude that the project should probably be pursued because it's unlikely that anybody would require more than 72% return on the project. So it must be that the required rate of return is somewhere in here. So it's probably going to be accepted. So the idea here is the benefit of doing this. Why are we doing this? We're doing this because we don't know what discount rate is acceptable. What is the required rate of return? Maybe we don't know. We just want to see a range of discount rates that would be acceptable and lead to a positive NPV project. So this one clearly shows that the project should be pursued because most people, most companies, most investors will be satisfied with a return, required rate of return in this area. And so this gives you the return on investment that exceeds any of these. So what we've done is I've taught you how to deal with a general case of cash flow. It doesn't have to be a strict investment project that you analyze. You can analyze any stream of cash flows. You need to make an NPV profile and interpret what are the conditions? What is the discount rate that management could set for the project to be profitable? Here's one more. And it results in this NPV profile. So notice, let's go back here for a minute. If you enter these cash flows into your calculator, you're only going to turn out, I think, this one, 70. Let me do that. Let's try and get the internal rate of return out of the calculator. If I ask for I or R and compute, no, that's not it. Aren't these the values that I was using? 900, 1200, 1300, 1200. Or maybe I changed them. Well, that's weird. Oh yeah, that's the negative. Oh, it's giving me the negative one. It's not giving me the positive one, so I'm only getting the negative one. But there's another one, and you have to try and find it. If I store a value, so in the HP calculator, if you store a value, and then you ask the calculator to compute it, it can find the other one, but not this calculator, unless somebody knows how to do it. It only finds one, the negative one, negative 2935. Okay. Questions, please. If NPV is equal to 0, you are indifferent to accepting the project. But usually, we say NPV is positive to accept. So if NPV is 0, no, do not. No questions? If you don't have questions, I'm going to continue. So here's the last one before we continue with the material. I think this is the last one. You need to tell me if I'm going too fast. I have no idea Are you caught up? Cool. So make the NPV profile for this. Okay, how are you? So for this one, you can use your calculator, and I ask you to compute the NPV profile. The profile means that you try different values of the discount rate in the formula. So we set it up with a percentage and the NPV, and we pick some values. We can start more broad, so let's say we start 0, 20, and 40. Let's do that first. And then, so for these cash flows, there are two sign changes from positive to negative and then negative to positive. When the first one was negative, you noticed if CFO was negative, the curve looked like this. If CFO is positive, it's probably going to go up. So let's see for these cash flows. If I enter these cash flows into my calculator, it's going to be, okay, I need to clear first the calculator, and then I start to enter 660 and then 650 negative, enter down, down, 750 negative, enter down, down, 50 negative, enter down, down, and 850, enter down, down, and we see our entries. Looks good. And we ask for the calculator to compute IRR, compute, and we get 805. So we know the answer is 805, but I asked you to compute the profile. To compute the profile, you can show, because there's might be another IRR. The calculator only finds one. So let's tell the calculator, put in 0 as the discount rate and compute IRR. Okay, well, let's put 0, 0, enter down, and now compute, and you get 60. So 60 is the NPV when the discount rate is 0. What about 20? At 20, 20, enter down, compute the new one is now a negative. It's negative 21.52. So this is negative 21.52. So between 0 and 20 is one return, one IRR, one place where the NPV is 0. And we actually found it. What about if we put in 40? Let's put in 40. What happens? So I hit NPV. I enter 40 as the interest rate, enter down, and then ask to compute again. Now it's positive again. So what does it mean? It means, sorry, it was 16. 16 So there has to be another place where NPV is 0. So it means that mathematically there should be a IRR in here, and there should be one in here. And when I graph the whole thing, so you could keep picking values, little to sharply define this, it turns out there's one here, the one you got from your calculator originally, but if you try and iterate, you can find this one, almost 34%. And what is the conclusion? As promised, the curve is up now because the first cash flow was a positive, and the interpretation is different. The interpretation is now that as long as management sets a required rate of return less than 8% or higher than 34%, you should accept the project. So why is this? If we look at the cash flows, initially it looks like a finance project, then we deliver the project, right? So that has an expense, but at the end, there is this relatively high cash flow that even though it's out in the future, it's enough to offset the losses, provided the discount rate is either low or high. If the discount rate is small, then it won't affect this 850. 850 from a perspective of today will be a lot more than if the discount rate was higher. A high discount rate will reduce the value of some of these over here, but yet still allow the initial cash flow and the one in year 4 to be make the project profitable. So this is why you see this pattern. Nope, there is no other way. If you buy an HP 10B2 calculator, you can try and get both. Sometimes the calculator doesn't even give you an answer. You have to use the profile. So in the exercises, in the examples I gave you instructions on how to compute the profile. So you have to get all these values and sketch the curve and make the interpretation. So to find the second one, there is no other way. I know the HP 10B2, the Hewlett-Packard 10B2 calculator will get both IRRs automatically. Nope, that's the formulas. There's no other way. I don't know why you want another way when you have a way, but it's good to have different ways of doing things for sure. So when you solve these problems, what I want you to present to me in a test situation is I want you to give me this expression and then the result, okay, to demonstrate to me that you understand what the IRR is. The IRR is the break-even discount rate. It's the one that will make the project not a loss, not a benefit, but from there, the project is profitable. Okay. questions. So in the last example, accept the project provided the required rate of return is between 0 and 8.05 or greater than 33.96. So now I'm going to go back to the intro page to the internal rate of return and review what we learned. What we learned about the internal rate of return, that it is the discount rate that sets the NPV to 0. We make an assumption that I haven't mentioned, that the IRR calculation assumes that all future cash flows are reinvested at the internal rate of return. To evaluate independent projects, all we do if it's an investment project is we accept the project as long as the internal rate of return is greater than what's required. You cannot do it like this if you have a finance project or if you have multiple internal rates of return. So we developed methods to deal with that. I showed you how to use an NPV profile to help you with the interpretation of what the internal rate of return is giving you. And that brings us to the problem of mutually exclusive investments. That's what we're going to talk about next. But having said that, I want to just mention the advantages. What's the advantage of the IRR? As confusing as it might seem right now, it's very easy to communicate a percentage and explain to people this is your return on investment in terms of an investment project. And that can make it very useful. Also, it's so useful when you don't have a pre-specified discount rate for calculating the NPV, and it gives you a whole range of values that would make the project acceptable. That's the real value of this rule. So it gives you that added information it gives you a range of acceptable discount rates. Okay, so we're going to do this next. What are the problems with mutually exclusive investment projects? So we're going to look at two projects now and talk about how to choose between them. So there are some issues. I'm not sure why this very strange. What's happening? Oh, I don't know what's happening right now. It's that because I pressed that number. There we go. I think it has the camera on. I have to turn that off. Okay, there we go. Okay, so there are problems with using the IRR criteria when choosing between mutually exclusive projects. And I'm going to demonstrate why that could be. The first problem, it arises out of a scale problem. So imagine this scenario. You get to choose between two options. Opportunity 1 is give me $1 now and I'll give you back $1.50 at the end of class. Compare that to opportunity 2, where you give me $10 now and then you get back $11 at the end of the class. Which project do you prefer? I mean, which opportunity would you take, 1 or 2? You can put it in the chat. Keep going. Thank you, Francep and Jean. Who else? Keep going. So far, everyone has picked Project 1 or Opportunity 1. Come on, who else? Okay, others are not sure or they don't want to pick one. So everyone who chose Project 1. What they're thinking is, excuse me if I'm wrong, but I think the logic is that you get 50% back, right? It looks, in percentage terms, this looks like the better project. Here this is 50%, and here it's only 10%. But that's not the right way to look at it. And most students get this wrong, so don't feel bad for making a guess. I just want to demonstrate that the flaw in your logic. So you are thinking, I'm getting 50%, not 10%, but that's not the way to think of it. What it is in dollar terms, you're getting a full dollar back with Opportunity 2, and you're getting only 50 cents with Opportunity 1. I've eliminated any risk. You're going to get your money back. You're going to earn this for certain. There's no risk. As long as you have the $10, Opportunity 2 is the better opportunity. Okay, so I assume you have enough money. Let's write the assumptions. Assume you have at least $10, and what was the other thing I said? I said, no risk. You're going to get your money back. So in that case, right, so we have to assume you have at least 10, okay, to do this. So then, in that case, you should look at the dollars, not the percentage. The problem is a problem of scale. These are different scales of project or opportunities. This is the lower budget project, and this could be seen as the higher budget project. So when you're comparing projects, they have to have the same scale, or you have to be cautious about how you interpret the percentage. You have to scale them or rescale them, making them relative, okay? In fact, if you use the NPV will give you the right answer. Here I use an artificial, I just made up. Let's say this was the discount rate over the hour and a half of class. And that shows 50 cents as your return, but here it's $1. In terms of NPV, the dollars gives you the right answer. So NPV will always give you the right answer. Even think about what we did with the IRR just now. We were looking at the NPV rule to make our decision. So NPV will give you the right answer. But how about the internal rate of return? Can we fix it? Can we fix it that this is showing us that we should invest in 1 over 2, but that's not correct. So how can we fix it? So we're going to talk about that in a minute. First, I want to demonstrate another problem. So just in conclusion, the NPV rule indicates that the present value dollar returns is more important to us. Okay, so we are going to lean on the NPV rule. And in this case, the way that we're doing things is not the right way. We shouldn't be ranking percentages. That's not the right way to solve this problem. Let me talk about this problem first, and then I'm going to teach you how to deal with it, okay? So this is known as the timing problem. Sampur, what about the opportunity cost of the additional $9 for project 2? I'm not sure of your question, but for opportunity 2 is the better project. I think you're talking about the extra 9 here. Anyway, making your money work for you, opportunity 2 is better. I'm assuming that there's no other project. These are the only projects available, okay? let me write that as a further assumption. Maybe that will help. No other opportunities. Well, except the discount rate that I'm using here. I'm going to say no other projects available, no other opportunities like those available. Okay. Okay, so we'll assume there's no other opportunities and this works. Okay, so the timing problem. Here's an example. What you have here is that the initial cash flows are similar. They're both negative. This is an investment project. A is investment and B is an investment project. But look at what happens. This one has cash flows that gradually increase, and this one has cash flows that are higher but gradually decrease. Because the timing is flipped in the cash flows, this creates, if I was to make an NPV profile of these projects, and they're both investment projects, so they would be going down. So A would be like this, and then you'd have to see is B above or below. But what ends up happening, the way that it goes, is A and B will cross over each other, because if you look at A, a high discount rate would be really bad, because that would make $200 not as worthwhile or valuable today. So you need a low discount rate to have a high profitability of this project. Okay, so you need a low required rate of return. For project B, you don't need a low required rate of return because the cash flows are around the corner. They're not. I don't rely or depend so much on 75. So I could have a high required rate of return for project B. It wouldn't matter. So what happens is the low required rate of return makes NPV of A greater, but the high required rate of return makes NPV be greater. So what happens is it's going to be like this. Or let me do that again. So B has a higher NPV than A after some point. Okay? A is going to have a higher NPV than B for low discount rates. So in general, it's sometimes you pick A over B, and sometimes you should take B over A. I'll erase those, All right, so what's going to happen if you calculate the internal rate of return of A with your calculator? You get 12.91%, so this is low. If you calculate the internal rate of return for B, it's 17.8%. So it's telling you, if you were to just rank them, it looks like this gives you a higher return, but that's not always true. B is not more profitable than A for low discount rate. So what we really need to know is, what is this crossover rate? So I'm going to show you how to get it. So we do not rank IRRs. We have to do, when we compare projects, we have to do something else first. So we have to adjust the internal rate of return rule for selecting between mutually exclusive projects given either the scale problem or the timing problem or both problems. You could just use the NPV rule, that will give you the right answer, or we use what's called the incremental internal rate of return rule, or incremental NPV rule. You subtract the cash flows of the smaller budget project from the larger budget project, or so that the initial investment is a negative. Okay? You can also do this, you can make it a positive for finance projects. I always try to make it a negative because investment projects are easier to understand. So this is where they don't cross, right? If they didn't cross, you would pick B over A in all instances. But this is our situation, right? A here, but B here. So these are the two sets of returns, not returns, but dollars. So what we're going to do is calculate the difference. I want you to subtract A, we're going to create what's called project A over B. Subtract B from A, and what do you get? So 350 negative minus 250 negative is negative 100. $50 minus 125 is negative 75. 100 minus 100 is 0. 150 minus 75 is 75, and 200 minus 50 is 150. So now what we have is called the incremental project. And what we're analyzing is we should take project A instead of B as long as NPV is positive. Or using the internal rate of return, we find it and we check and compare it to see the discount rate. So what you're going to find when you get the internal rate of return from here, you're going to find the crossover rate. You're going to find this here. Okay. So putting those values into your calculator, negative 100, negative 75, 0, 75, 150. So you put 100 negative, oops, didn't work. Second, clear work, okay. So 100 negative, that didn't work. 100 negative, enter, down. So that was first 100 negative, then negative 75. 75 negative, enter, down, down, then 0, enter, down, down, then 75, enter, down, down, and what's the last one? 150, and then 150, down, down. So I have the values: 100 negative, 75 negative, 0, 75, 150, and you're asked to compute IRR, and there it is. So that is the crossover rate, and it changes the decision. It marks a change in the decision of which project to take. .07. And so now you see the interpretation is, as long as the discount rate is lower than 8.07, choose project A. If the discount rate, that the required rate of return of the company, is greater than 8.07, then pick project B. But projects should not be chosen, project B should not be chosen for discount rates higher than this. It'll lead to a negative NPV. But this is just the dividing point between A and B. So discount rates higher than 17% means don't accept project B either. No project should be accepted. So you need to get straight what I'm talking about in terms of internal rate of return and the required rate of return. I use the word discount rate for both, so hopefully you can resolve what I'm talking about. Okay, so that's a threshold. 17.8 means don't accept B or A. Any questions? So I've just shown you how to pick between projects properly. If you use the NPV would give you the right answer. But let's say you don't know what discount rate you want to use, so you can make the NPV profile, calculate the internal rate of return, and it gives you a range of values you can present either to management or to the investors, or on which you can ponder whether your project will be profitable or not. This is just a summary of what I've said. And just note, we call this the incremental project, A over B. Okay, any questions? So these projects, these numbers, what we're gonna do after we finish this unit. Today I'm gonna continue right now. I'm going to show you the last kind of technique for determining whether to pursue a project or not that we're going to talk about in this course, and then we'll do some exercises together. Then later this afternoon, maybe I'll do a couple more exercises and introduce the capital budgeting topic. In capital budgeting, we're going to figure out how to determine these cash flows. Where do they come from? So in this set of cash flows, what is the problem here? We have here a problem of timing of cash flows, right? Because these cash flows, the first project, the $200 is higher than the rest, but in project B, they start out high and they go low. So project A prefers low discount rate, as we see here. That's where we pick A for low discount rates. But project B prefers high discount rates. I mean, it's more profitable for high discount rates. Okay, you guys are silent. I am going to continue. This is the last kind of rule we're going to look at. It's called the profitability index. So just to review, NPV gives you a dollar amount that you use to evaluate projects. The payback period rule and the discounted payback period rule give you some measure of time as a metric to evaluate a project. And the IRR gives you a percentage, and you interpret it as the return on investment if it's a investment project, or as a rate of borrowing for financing in a finance project. And we learned a lot of things about that, but we really work with the percentage. Now, to do this, in each of these cases, in NPV, we figure out cost against benefit. We add them together, right? In IRR, I figure out, again, it's like an NPV. I'm doing the same sort of thing. I'm getting a percentage. What if I make a ratio instead? The profitability index is a ratio putting the benefit divided by the cost to see if it's worth it. What is the value of the project in terms of bang for your buck? You say bang for your buck. Per dollar. So this is putting the benefits, this is the present value of future cash flows divided by the initial investment. And I'm going to do this for investment projects only, not finance projects. And what you do is you let your initial cash flow, make it a positive, okay? So take the absolute value. And so I have a new variable called CO. Because usually initial investment is negative, right? For investment project is negative. So what happens here is all you want are the future cash flows. You don't want the initial one. You want this to be all benefit at the top. So you're going to take the net present value that you may have calculated and add back the initial investment. So all you have on the top is the total present value of future cash flows. And what you're going to do is, for an independent project analysis, is just pick that project or select it if the profitability index exceeds 1. If you have several projects, you can calculate the profitability index and pick the one with the highest profitability index if you can only afford one project. There's a problem again with the profitability index as with the internal rate of return. You have to evaluate the incremental project instead of the one with the highest PI. You might have a problem, okay? Because this will work, but if you have a scale or timing problem, you're going to have to do the same thing that we just did. So if there's a scale or timing problem in the cash flows, we have to study instead the incremental project. So why is this good? This is a good method because it's easy to understand and communicate. It gives you a ratio that you can interpret as bang for your buck, or for each dollar invested, what is your profit? And it will help you arrive at the correct decision when evaluating independent projects. And one additional thing that I'm going to discuss is it's very useful when doing capital rationing. When you have when you have limited funds, but you can afford more than one project among several. It can help you make a decision efficiently, and I'll show you how. All right, so here's my project. It's a very simple 2-year project. The initial investment is $1,100, and this is the discount rate. Notice I used a new term, the hurdle rate. This is the one we have to reach over, right? Hurdle. We have to jump over here to make the project profitable. So that's the idea of that. So in terms of the profitability index, first you're asked to calculate the net present value. And so we should write out the equation first. The equation would be, do I have it here? Yes, I do. This is the equation, and you can put this in your calculator to find $180.99 is the net present value of the project. So this says by NPV, invest. So we already know the answer, but let's get the profitability index. So to get it, what you do is you take your NPV and you add back the initial investment, which was this amount. So you're taking the NPV and you're adding back the initial investment and then dividing by the investment to determine the per dollar reward from the project. So when you put these together, you get this amount, and this was the investment. So your profitability index is 1.2. 1.2 is better than 1, so you invest. That's the rule. Accept the project. This is a good project because you get more than you invested. Any questions so far? No comments? Okay. So no questions. So this is how you would calculate the PI. I want to do an exercise before I continue. Let's look at exercise. Let me see which one I want you to open. No, not that one. Let's do this together. Drake Corporation is considering the following two investment proposals. As a financial manager, you are responsible for making a recommendation to the board of directors. The projected cash flows for the project X and Y are as follows. Calculate the NPV, the IRR, the PI for each project and fill in the table below. Assume that the discount rate is 12% and show all your work. So what I want you to do is do this for NPV, IRR, and PI. So you need to write all the formulas out. So for NPV, you would write negative 750 plus 600 over 1.12 plus 300 over 1.12 squared plus 150 over 1.12 cubed plus 75 over 1.124 plus 60 over 1.125. And then use your calculator to get the amount. And that would be NPV of project X. And then NPV of project Y, you would do separate. Then you do the same thing for the IRR. So this one would be negative 825 plus 75, 1.12 plus 150, 1.12, 300. So looking at the cash flows, do you see a problem that will affect a comparison of these projects? What you have here is a timing problem. You see, X has high cash flows initially that go down, so it favors high discount rates. And project Y has high cash flows at the end, so it favors low discount rates. So if you have a discount rate of 12%, how does that affect things? Can we make a decision, accurate decision? So this is what I expect you to write in a test situation. So what do you get for the first one? Yes, Justin, that's right. Can hold for the first one, 213. I gotta check. Let me see. Very good. 213. $213.35. What about project Y? Very good, Francette. $230.46. Very good. Good. So if you've done that, let's move to the IRR. And what you have to write is IRRX with a colon, because the result of the NPV is 0, not IRR. IRR solves the equation. So I have to recopy what I did before. But not with this. I have to include the symbol IRR as the discount rate. Okay, so that is how you express it, and then you say you give me the solution. Very good, Canol. Oh wait, Canol, you got it wrong. Check that one. Verify. Very good. Very good, Canol. You found the mistake. Yep, good. Okay, let's see. Is that the internal rate of return of x? $29.97. Very good. Yes. 29.97%. Very good. 2 decimals is fine. And then let's do y. So you have to write out the expression. Just to foment the idea that this is where it comes from. To put it in your brain. Oops, I'm doing it wrong, aren't I? You have to put the I or R in here. I'm copying. And this is equal to 0. So when you solve in your calculator, what do you get? So how about this one? What do you get? I get 19.66. I get 19.66, as does Francette. All right, so we've done this for NPV and IRR, and what do we conclude? If we can pick one, both of these are profitable, but we can only afford one, then we should pick Y, right? according to the NPV rule. In terms of so ranking by NPV, you would pick Y. If you rank by IRR, however, it looks like you should pick X. But which one is the correct answer? Which one is correct, X or Y? So we just learned earlier that when there's a timing problem, this is the cash flows run backwards to each other. It could be okay, that when you rank IRR, you rank PI, they're going to fail. Instead, we should analyze the incremental project, which we will do. So the best answer so far is Y is the project. But I haven't asked you to do that. I just asked you to calculate them in this part A, okay? So I'm anticipating the next part. So even though IRR says pick Y, sorry, pick X, you need to pick Y. That's right. Right. Very good, Monsieur Sever. All right. Let's do PI before we continue. So for here it's 1.284. And here it's 1.28. Well, I'll say 279. So again, they're both positive, but you have to pick one. So using PI to rank, we would pick X again, but that's not the right answer. All right, so this is the issue. The only one you would do to rank this is the one, NPV should be the only one that you rank and compare. When it comes to IRR and PI, you have to use, conduct an incremental project analysis. Okay, right. So CFO, if you look back at the formula, I'm going to get the formula back. So now by practicing this, you can see CO is not the same as CFO, you see? See what we did? We made it the absolute value here. So the first cash flow is made positive. So that's why I'm using the positive. In other words, you can't do this for financing projects. You just do this method for investment projects. Okay, so it's a good observation that you noticed. Do you see? All right, so now let's conduct the independent project, incremental project analysis. So if the above projects are mutually exclusive, the project to select using only NPV would be a Y, but if you only use IRR, you would pick X, and PI, you would pick X. But that has to be reconciled. You can't have different results. They should reinforce each other. So which one is the correct one? Well, we know that NPV gives us the right answer. So let's show how to get that answer. We're going to conduct the incremental project analysis. What I'm going to do is carry these down. Oops, oh no. Do that again. Okay. So what I'm going to do is I wanted to take y minus x. That would be better, because that will give me a negative first value, and I prefer that. So let's calculate y minus x, the incremental project. So I'm going to subtract this by this amount. I'm going to subtract on top, okay? And there you go. So now let's compute the NPV of the incremental project y minus x, the IRR of the incremental project y minus x, and the PI of y minus x. We're going to finish this and then we're going to go for a break. Did I make any mistakes? What do you get? So I'm going to put the expressions and then we're going to take a break because it might take longer than that. So I have to put a colon here, right? And I have to write, I have to recopy this. But with 1 plus IRR Oh, I forgot the squares here. Oh, sorry, 1, 2, 3, 4, 5. And I have to say that that equals 0. And I have to write and finally I'll do the PI. So I'm just going to leave the expressions up. So in this case, the NPV, well, I need the NPV to do this, and then the COs. Did you get y minus x or x minus y, Monsieur Sévère? Okay, so let's take a break and we will finish this when we get back, okay? And then we will move on to, we'll finish these notes and then learn the new material. All right, so let's take a break for an hour and we'll see you back here at 5 o'clock, okay? So we'll pick up from where we left off. Bye for now. Yes, Monsieur Sévère, I did y minus x. I mean, it doesn't matter. You could do it either way. You just have to be careful your interpretation in the end. Okay, that's good. You're trying to see if it's the same. Yes, you could do x minus y. You just have to think about what it means. So if you do y minus x, it means y is approved over x. I know it's going to be y over x. That's why I did it this way. Because the NPV told me. That's why I cheated in a way, because I know the answer. But in general, yeah, you could do x minus y. You just have to be cautious of the interpretation. So in the terms of net NPV, it does equal, and PI, it does equal. But here I put a colon because it doesn't equal it. It's used to solve it for it. Okay, let's take a break. I'm going to start a video for 5 o'clock, okay?